My name is John Grisdeel. I'm the CEO of Nine Water in Golden, Colorado. And my good friend Doug Jones is here with us today from Global Composite Piping Solutions. I'm a long-time entrepreneur. This is my 9th company, one of the reasons why we're called Nine Water. And almost everything I've done has been a spin out from the U.S. Department of Energy, although we also have licensed technology, especially for Nine Water, from a wide variety of institutions, including NASA and a couple of universities, University of Texas, New Mexico Tech. They've been very helpful in providing us with our baseline tech. So, Doug, why don't you introduce yourself and Global Composites?
Sure. So I'm Doug Jones, the CEO of Global Composite Piping Solutions. My background is primarily in the energy space. I was an investment banker for a long time, helping companies do mergers and acquisitions, financings, public offerings, that kind of thing. And then I moved into the pipeline space by joining a company as their chief financial officer and helped that company grow pretty rapidly from about 100 million in revenue to 750 million in revenue in about 2.5 years. So I know the pipeline space very well. I was approached by GCPS to come join them and help them grow their company about 3 years ago. So I joined them, and we've received our patent in 2018, and we've been through quite a bit since then to try and launch the company. And one of the things we're doing is trying to raise funding right now to do that, and that's one of the reasons we're on WeFunder.
Right, and so let's get right into it, Doug. Your company has a new way of building pipelines. What's wrong with the way they're currently built?
Yeah, so currently the big problem has been in the pipeline industry for decades now. Pipelines have been built with steel, cast iron, lead, concrete, and all of those materials have inherent problems. So obviously lead. When you're running water through a lead pipe, you can pick up some of the lead and create lead poisoning, which we saw in Flint, Michigan. And that happens, that's happened for decades in different places. So they replaced it with steel, and steel has the problem that it's very corrosive. So when you're running fluids or gases through a steel pipeline, it corrodes. It corrodes the steel. Both on the inside and the outside of the pipe. So if you have a little nick on your pipe when you install it and you bury it in the ground under soil, soil gets wet and you get rust and corrosion. But it also corrodes on the inside by a methodology called tuberculation. Tuberculation means that as the water is running through a steel pipe, it's corroding the inside of the pipe and creating little bumps or nodules inside the pipe, which then creates friction against the material running through the pipe and increases the pressure on the pipe. So when you've got corrosion on the inside and the outside, you're going to lead to failure, and it happens all the time. To address that, the pipeline operators began using concrete pipe several decades ago. The problem with concrete is it deteriorates. You run high pressure water across concrete for a long period of time, it's going to deteriorate. And those rupture, in huge fashion, huge amounts of water when a concrete pipe ruptures. So, the problem has always been that there's not been any other way to do it. There's not been a material that could hold high pressure required to move fluids or gases over a long distance for a long period of time. So it was kind of a problem that was a necessary evil. But today, with our pipe, we've created and patented a new pipe using high-density polyethylene, which is plastic, that doesn't corrode, it doesn't deteriorate, It'll last for, probably 100 years. And it can hold the high pressure, which historically, HDPE, traditional HDPE can't do it. Our technology takes an HDPE pipe and gives it rigidity and strength, and then it allows it to hold high pressure, which we think will be able to solve the problem of all the ruptures and the corrosion and the deterioration, and basically replace all the pipe used in the industry today: steel, concrete, fiberglass, traditional HDPE. We think our pipe will displace all of those.
Wow, that's extraordinary. So it seems like there's a lot of different industries that use pipe for a lot of different reasons. You got to start somewhere. What markets are you focused on now?
Yeah, so our initial focus is going to be on the water market, the water pipeline market. It's an enormous market. We have a project down in South America that we have an agreement on to build a pipeline from a remote water source to a new large agricultural development. And they chose our pipe because it is much cheaper than their alternative. It's easier to install. It'll last a lot longer, and it's significantly cheaper from a maintenance perspective than their alternative. And that's going to be the same, across all industries. But the water market, it is a multi-trillion-dollar global market. It is enormous. It's estimated at over $1 trillion annually needs to be spent to maintain and upgrade our water infrastructure around the world. The issue has been nobody really knows about our pipe. And in the U.S., to buy our pipe and use in a municipal situation, a new pipeline, we have to have certification. So that's one of the reasons we're trying to raise money, is to go through the process of getting our pipe certified for use in the U.S. municipal water market. I think once we have it certified, it's going to be a game changer. I think we will dominate the market. I can't imagine why anyone would ever want to use steel or concrete again when they would have the option to use our pipe. But we have to get it certified so that they can buy it. But we're not limited just to the water industry. Oil and gas, distillates, hydrogen, all of those markets use pipes, like you said. And they still have the same problems. They're using steel primarily to transport crude oil and natural gas, and they have real problems. They spend a ton of money on cathodic protection. Hundreds of millions of dollars in maintaining their pipe, because if you have a failure on a crude oil or a natural gas pipeline, it's not like water leaking out. It's a catastrophic issue with one of those pipes leaking. So that's what we'll target, and we're also going to target getting certified for those industries as well once we start our certification process.
Yeah, it seems like we always hear about oil spills out of pipelines, and pipelines are very controversial, mainly because of that. You think about the Keystone Pipeline. The fear is not that we're giving up some economic position for Canada to ship its oil, it's rough crude overseas. The fear is that pipe will leak. But I heard something really interesting where you had said that we're losing as much as 6 billion gallons of water every day. How can that be? How are we losing that much water every day?
Yeah, it's kind of crazy to think about. That's a huge number, and I'll put it in perspective here in a second. But the problem is, like I mentioned, steel and concrete are leaking every day and rupturing every day. In fact, we have a mainline water rupture every 2 minutes in the United States. So you think about that. During our webinar here, we're going to, in the U.S., experience between 10 and 15 mainline ruptures somewhere in the U.S. That's crazy. And what does 6 billion gallons of water mean? So It's a huge number, but I tried to put it in context for people to understand what that number is. That number is enough water to service 73 million people every single day. So that's enough water, and I've got a list here, to supply every resident in Kansas, Mississippi, Arkansas, Nevada, Iowa, Utah, Connecticut, Oklahoma, Oregon, Kentucky, Louisiana, Alabama, South Carolina, Minnesota, Colorado, where you are, Wisconsin, and Maryland. That's every single resident in all 17 states every single day. That's how much water we use. So we have to fix the problem. It's a huge problem. It's not just in the U.S., it's global. But I mean, if we care about our environment and our resources, and water is one of our most precious resources, then we should all be demanding that we fix the problem. Imagine 73 million people in 17 states we could be supplying water to with just the leaked water that we have every day. And it costs water utilities about $8 billion a year and lost revenue from these leaking pipes. And who pays for that? We do. We pay for it in our water bills, and it's only going to get worse. And you've probably seen your water bills increasing over the last few years. And if we don't fix it, it's gonna really be bad. So
I like the idea of not having to replace water lines. We're not, as you know, we're not in the municipal water business, but I'm, like everyone else, a municipal water consumer, and the cost of water keeps going up and up. And I've got to believe that some of that has to do with this loss you're talking about. So with GCPS's pipe, you're saying we're not gonna have to replace the water pipes or later other kinds of piping every 30 to 50 years? How? I mean, what does that solution look like to the average investor?
Yeah, so great question. So, like I mentioned before, the main component in our pipe is high density polyethylene plastic, HDPE. HDPE has been proven to have a life expectancy of over 100 years. So we won't have to replace our pipe every 30 or 50 years. We won't have to do patchwork or repair work. I mean, once our pipe is installed, it's virtually maintenance free. I mean, the only maintenance you're probably going to have to do is on your pumps and maybe your valves. But the pipe will last for 100 years or more. So we could replace all the water pipelines in the U.S. And if we were to do that, we could save over the next 100 years 210 trillion gallons of water over that time frame by just using our pipe instead of incumbent steel or concrete.
That's incredible. And HDPE, by the way, we use HDPE tanks for our 9 water system. So we're probably a lot harder user than you guys are of that particular material. But compared to PVC, Donald, one of our listeners, has asked about PVC and the way it leaches in the water. Does HDPE leach in the water like PVC?
No, it does not.
Okay.
Yeah. And, PVC is not, the name defines HDPE, high density polyethylene. So,
okay.
In fact, we're working with one of the chemical HDPE manufacturers on potentially making a HDPE that's so dense we can transport hydrogen, which is a very small molecule. And right now, when they move hydrogen, it has to be trucked through tankers. And if we could make a pipeline, it would really change the hydrogen market.
Absolutely. So I got to ask, what is the catch? Doug, you say you've got a better, faster, but what about cheaper? I mean, not just in terms of life of pipe, but talk a little bit about the cost profile.
Yeah, so I mean, from a cost purchase standpoint, upfront, we're competitive with steel. And we can beat steel on their pricing as well. And we're much cheaper than the concrete pipe. That's very expensive pipe. And the concrete pipe is generally used you know, in the water market to avoid, you know, the corrosion of the steel. And when you get to really large diameter, I don't even think they make steel pipe that could be in the very large diameter market. So we will be substantially cheaper than the concrete pipe, but we're also cheaper than steel. But then when you factor in installing the pipe, it's much cheaper and easier to install HDPE pipe than it is steel or concrete. You don't have welders. Our pipe is fused together, so you don't have a crew of 10 or 15 welders out welding up the pipe and worrying about whether there's a pinhole leak in the weld. Ours is fused together and doesn't have any leaks. The other thing is the maintenance. You mentioned it. I mean, maintenance for a steel or concrete pipe totals in the tens or hundreds of millions of dollars over the life of a project, even up to probably $1 billion on some big projects. Just maintaining the pipe, doing that patchwork, doing the cutting out a segment, putting in a new segment. For 100 years, it's going to cost hundreds of millions of dollars. The other thing that we have that we haven't really mentioned is we have a patent on our manufacturing equipment. So we have a design where our equipment is mobile. So we can pack up all of our manufacturing equipment, take it to a job site or near a job site and manufacture the pipe at or near the project site. This saves a tremendous amount of money on transportation charges. In fact, the project in South America, we're probably saving them north of $20 million in just transportation costs by making the pipe at or near the job site. The other thing is, I mean, if you look at all the trucks that it takes to ship pipe to a project site, I mean, it takes a lot of truckloads. It could take thousands. If you see these trucks going down the freeway that have, one very large piece of pipe on it, or maybe 4 large pieces of pipe, that's a lot of truckloads. And it's expensive. It's dangerous to have all those trucks on the road. The emissions that come off from all those diesel trucks, I mean, with our mobile manufacturing, we're saving tens, if not hundreds of millions of dollars on a project. We're eliminating emissions, and we're making the highways safer for the rest of us to drive on. So, it's a win-win across the board.
Yeah, as you know, I've traveled all over the world. I've been in Kazakhstan and Siberia and in the wilds of Brazil, and it's amazing to me the effort required to move 3 pieces of pipe.
Yeah.
On a semi, and literally you've got a band of like 15 or 20 guys pushing the semi through the mud. It's just crazy. So with your equipment, you can go locate there, and then you're just bringing supplies in, right? The raw materials, but the factory is located there. That's very similar to what we're going to be doing in California with water treatment. This distributed manufacturing of a infrastructure is really key, I think, in making sure that we create something that's not only more sustainable, but more lasting.
Yeah, absolutely. Y'all's technology, we've been fascinated with it since we've been working with you and talking with you guys about what y'all do. So, I know some guys that work in the wastewater industry, and so I know a little bit about it, but not a lot. But what exactly is y'all's focus in the wastewater market?
Well, what we've defined is a space called unconventional water resources, and that can be wastewater from an industrial plant. It could be oil and gas produced water that comes up, with the oil and gas from the formation. It can include a lot of water, quite honestly, that's either too expensive traditionally to treat, or they're kind of water fat regions, and so they throw away their water and contaminate everybody else's water. So we're kind of fighting. Apologies. We're kind of fighting. Our market is industrial wastewater, and it's very, very specific. But unconventional water also includes things like brackish water. This could be groundwater that's not fit to use for agriculture, but needs some treatment. And, unfortunately, everything that's underground, including hydrocarbons and arsenic and all these metals, is going to come up with that water. And that's why it's conventionally, very expensive to treat.
So you mentioned oil and gas, and you also mentioned that you're going to California. I mean, what other geographic markets are you focusing on, and the type of wastewater you mentioned? But are you looking at West Texas? Are you looking international?
We're really focused on the low-hanging fruit, and those are customers that have very specific problems, like, say, chemical manufacturing plant in the Pacific Northwest, and they're not meeting the regulations for discharging their water. And what we're going to be able to do is not only treat their water for less than it costs for them to pay the city sewer, they're going to be able to recycle that water into their cooling jackets at the plant. So that means they're not only going to stop paying to throw away water, they're going to lower the cost of bringing new water into the plant. So again, it's because of our cross structure, and how much more or how much less it costs to use our products that really make us, stand out.
Yeah. So, I mean, that sounds fascinating in terms of different markets. Why do you think that you'll be successful? What other technology, environments are you putting your technology in? I mean, what makes it so special?
Well, I'll tell you, the conventional approach to treating wastewater involves a lot of concrete. You build a very large plant, because one of the easiest things that you can do with this kind of unconventional water is let it sit out in the sun. And then particles that are in the water will eventually drop to the bottom of a very large catch basin. So imagine, a plant that's 20 football fields in size. Our technology allows us to create a machine that replaces that large plant in that slow process. And the key is that the folks at Los Alamos and New Mexico Tech came up with some very, very effective and low-cost reusable media. Now think about this: when you've got your pure water filter, hanging off of your kitchen sink, what happens after several months? Well, it's done its job and you throw it away. Inside that cartridge is what's called activated carbon. And activated carbon is used in a lot of the applications that we can come in and solve. And it's very expensive per cubic foot, per cubic meter. Our media is not only less expensive and just as effective, it's reusable. We can recharge our media in the field. So we've got special media for metals, we've got special media for sulfur compounds, another kind of media for hydrocarbons and things like that. And they all use either salt water or air to recharge the media in the field, or as we say, at the plant. Now, if you need to buy 40 tons of activated carbon compared to 40 tons of our media would cost you about 20% of 40 tons of activated carbon. And it'll last through 500 to 1,000 cycles. It's very different than activated carbon. You sell machines because it's tough to push water through this particular media, and the computational fluid dynamics were done at Los Alamos. The original work goes back to New Mexico Tech, a guy named Rob Bowman, that had been working with these different kinds of nano-coated, naturally occurring media. So our media is actually mined, and then we apply a innocuous nano-coating to it that's tuned to the specific kind of contaminant that we're trying to remove. So that, again, that's metals or hydrocarbon or sulfur, even radioactive materials.
Wow. So
I know it's a lot of science,
yeah.
but it comes in a nice little package on the back of the semi.
Yeah, very cool. You mentioned earlier this is 9 Water. It's because it's your 9th deal, 9th project. I know you and your team have been together for a long time. What else have you guys done?
Well, we started spinning, the first company we spun out of Los Alamos Laboratory 30 years ago. And I can't believe it's been 30 years. I mean, the last 20 have just blown by, but we've been fortunate to have a very cool, set of careers. That company actually, burned down and fell into the swamp, but the next company stayed up, and it was in digital imaging. But we've done projects together, the management team over the last 30 years that include a medical device, small nuclear power plants, control systems for machines and for very large experimental devices like cyclotrons and linear accelerators, and so we've built this kind of neat group that takes other people's technology and then designs industrial products. We've never done consumer products. Being a consumer, I would never want to meet me at the other end of a transaction, but we've succeeded in taking this kind of really advanced technology, turn it into a product that people can use to save money or solve a specific problem. And so that's what we've done. Yeah, it's been 30 years.
Wow, that's awesome. So you mentioned with all of these different projects, I'm sure you had to raise capital previously. Why are you doing the crowdfunding on that 9 Water?
Well, I think crowdfunding has really changed a lot of things for us as a company. We traditionally would fund our ventures using venture capital. And right. I was a venture capitalist for a hot second, and I've also run a couple of funds that invest in real early startups. And the problem is the venture capitalist, he's got to be right maybe 2 or 3 times out of 10. And over the long haul, the company sort of, they're really not succeeding in their own terms. They're succeeding in the eyes of the venture capitalist. Now, when we first started development in 2012, we didn't know how long it was going to take to get a product to market. We had science, right? Science has unknown outcomes. We had scientific facts, and we had, all of these advancements. And then we had to engineer a product and take it out into the marketplace and test it, and then come back to the to the shop and refine it. And we did that over a number of years. So, we really couldn't predict when first revenue was. It's very difficult to get a venture capitalist or mutual fund to invest when you've got unknown outcomes. With crowdfunding, it's about a lot of people investing a modest amount to have a huge impact. So we have almost 3,000 individual investors now, and I love them. Wow. We have some guys that are really active in the company that contact me on a regular basis. Other people that put their money in and they're just going to wait, for our exit in a couple of years. It's easier for us to manage the company because we don't have sort of this one person overlooking us like you would a venture capitalist who, really their perspective, their needs come before the company. Instead, what we've created is a movement about increasing, or I like to say manufacturing, new water using unconventional water supplies.
Yeah, well, that's the same reason we went the crowdfunding route as well. Having been an investment banker, I've dealt with a lot of private equity. The pipeline company that I helped build, we sold to private equity. So I know what those guys are like, and I know what the venture capital guys are like, and they do a great job. They serve their purpose, but like you said, I think working with regular people to invest in the company is what our objective was, so that they could participate in what we all hope are, fantastic returns when we do an exit. So we had this same feeling about doing the crowdfunding that you do.
Well, and also the neat thing is that we've made a lot of leads for potential sales. I'm not sure, how you guys have done. In a couple of cases, it might be that somebody, they invest through our crowdfunding round at WeFunder, and it's because they have a personal, interest in our success, i.e., they think their company could use our products. But mostly, it's somebody who knows somebody. You know, we get, you know, like end users. We have a lot of farmers and ranchers investing in Nine Water because that's one of our not end user markets, but that's where the benefit will go, is taking these unconventional waters in high drought areas like Southern California and being able to manufacture water to grow crops. So that's another neat thing about crowdfunding.
Yeah. Well, do you want to disclose what we're doing together?
Yeah, I think it's a good opportunity. You know, folks, Doug and I have been chatting over the last few months and become good colleagues and believe in what each other is doing. And so we're putting together what I call a cross-marketing agreement. And simply that means that when I go out in the field, I'm going to be thinking not only about solving a problem in water treatment, but in transportation and using Doug's pipe. That's simply it. It provides us another quiver in our arrow to solve, you know, water shortages, regional drought issues.
Yeah, and the same for us. Obviously, when we're out talking to utilities, wastewater operators about preserving water, Nine Water's technology is going to fit right into us, you know, building pipelines for them. So I think it's going to be a great arrangement between our two companies.
Yeah, and you know, just the other day we got an inquiry from a community in Mexico, and you know, their drinking water is pretty good, but it's got arsenic in it, and it turns out that they're losing about half the water from the source to the small village, and so we can put a very modest machine, something that would fit in the back of my, you know, Ford Explorer, to treat just for arsenic for that number of people, but in all likelihood, they could use your pipe to replace their existing infrastructure so they don't lose half of it just getting to the village. So that kind of synergy is really exciting to us because we're solving the whole problem, not just part of it in this cross-marketing, you know, arrangement.
Yeah, exactly. So I don't know what time we've got, how much time we got left, or if you want to open it up. Are there any other questions that have come across?
I haven't gotten any other questions online, but you know, we're both of us happy to answer your questions. The best thing to do is to go to our WeFunder sites. Ours is wefunder.com/ixwater, and there's a place there you can ask questions, and then that way the answer gets to everybody who's interested in our crowdfunding. And Doug, your site at WeFunder is?
WeFunder /GCPS.
Okay, so it's just the company initials. Global Composite Piping Solutions, but you go by GCPS.
It's easier to say.
Yeah, well, it's definitely shorter. So, all right, well, thanks a lot for your time, Doug. I think this has been super. I'm really excited about our new relationship and our ability to put each other's, you know, products to work to solve problems for, you know, for real users out there that need it.
Yeah, I agree. I'm looking forward to working with you.
All right. Thanks, everyone. Appreciate you attending our webinar, and we'll see you again soon.
Thank you.